ನಾನು ಟ್ರೈ ಮಾಡ್ತೀನಿ.
Yes, sir.
Sir, it started.
Started.
Yes. Trupti madam, you can go
I
ahead.
request all the participants and those to kindly mute themselves. A very good morning to one and all. I, Trupti Tagare, Assistant Professor from Department of Electronics and Communication Engineering, Dayanand Sagar College of Engineering, on behalf of the management, Dr. CPS Prakash, Principal Sir, Dayanand Sagar College of Engineering, Dr. T.C. Manjunath, Professor and Head of Electronics and Communication Engineering, and the entire DSI family welcome each and every one of you to today's webinar on advances in wireless sensor networks and its security. I wholeheartedly welcome our distinguished speaker, Dr. I also welcome all the participants and my colleagues to this webinar. The webinar aims to extend the knowledge of participants in the field of wireless sensor networks and its security. Prayer is not asking. Prayer is putting oneself in the hands of God. Let's pray for the health, happiness, and success of each one present here and seek the blessings of the Almighty. On this positive note, let's begin our today's webinar session. I request Dr. Pavitra Ji, Associate Professor, Department of Electronics and Communication Engineering, DSE, to introduce to all of us today's speaker, Dr. Nirbhay.
Thank you, Trupti ma'am. Can you hear me? Can you hear me over there?
Yes, ma'am. Yes, ma'am.
Okay. Good morning to all my dear students and staff. It's a great pleasure and privilege for me to introduce our speaker, Dr. Nirbhay Kumar Chaubey, who is going to talk us about advances in wireless sensor network and its security. This is a subject in which we should all be deeply interested. So all students and staff, please join me in welcoming Dr. Nirbhay Kumar Chaubey. I'll give a brief profile of Dr. Nirbhay Kumar Chaubey. Dr. Nirbhay Kumar Chaubey, currently working as Dean of Computer Science, Ganpat University, India. Prior joining to Ganpat University, Sir has worked as Associate Dean and Associate Professor in Gujarat Technological University. Sir has also worked as a Special Officer on special duty to the Gujarat Technological University for year 2011 and 2012. He worked as a project trainee in Space Application Center, ISRO, Ahmedabad during the year 2003 and 2004. Professor Chaubey received PhD degree in computer science from Gujarat University, Ahmedabad, India. His research interests lie in area of wireless network architecture, ad hoc network, sensor network, virtual learning. He has authored 4 books published by Springer, IGI Global, and published 51 research papers in reputed journals, Web of Science, international journals, published research works, all cited by the research community worldwide, which shows his expectational research performance. Google citations 456 and H index 13, active technical reviewer of reputed journals of IEEE, Springer, Elsevier, and he has guided several PhD, master, and postgraduate students for their quality research work. Professor Chaubey is a senior member of IEEE, senior member of ACM, and life member of Computer Society of India. He has received several awards, including IEEE Outstanding Volunteer Award year in 2015, Gujarat Technological University Pedagogical Innovation Awards, and also Outstanding Branch Counselor Award in the year 2010. So I'm very happy to introduce Dr. Nirbhay Kumar Chaubey to have here on this webinar. Thank you so much, sir.
Thank you,
Pavitra,
Professor Pavitra. Thank you, Professor Pavitra, madam, for brief introduction.
Thank you, sir.
Yeah.
Yes, sir. Over to you now. So please request you to start the session, sir. Thank you.
Thank you, Professor Trupti. And let me thanks Professor T.C. Manjunath, Dr. T.C. Manjunath. He's a good friend of mine, and I thank Professor Manjunath and entire team of Dayanand Sagar College of Engineering, Bangalore, for inviting me uh, to deliver whatever the research I have gained through my research journey. So basically, I have planned to the entire presentation by referring 20 to 25 journals and research conference papers uh, to target the audience of postgraduate students and UG students and few faculty members, those who are interested to carry out their research work in the area of wireless sensor networks. So please allow me to share my screen so that, okay, so.
Yes, sir, you can go ahead, sir. I have stopped sharing my screen. You can start sharing.
To save the bandwidth, meantime, I will be keep my presentation in on-off mode, my video, okay?
Yes, sir. Yes, sir.
Okay, sir.
Yeah, so my screen is visible, everyone, and I am
Yes.
audible.
Yes, sir.
Yes, sir. It's visible and it's audible.
Yes, sir.
Right. So again, very good morning to all my dear friends, especially Dr. Manjunath and entire management of Dayanand Sagar College of Engineering, Bangalore. So thanks for giving me opportunity to interact with UG and PG students and research scholars. Now, the topic of my talk is wireless sensor network and its security. So, a wireless sensor network is, it is a very emerging and lots of potential for research. And thereafter, once the network is established, WHN wireless sensor network, then comes the security. Security comes in picture once the network is there to protect your data, right? To send the data to especially targeted audience, right? Whatever the data is being transmitted over the communication channel should be secure. So many issues are there that we'll be discussing next one and a half hour, right? So this is the declaration disclaimer that the presentation which I have made by collecting many of the research papers and books related to the wireless sensor network. So this is not, I'm not going to cover my own contribution, right? But basically because the students are there and young researchers are there. So I thought, why not collect these informations and start with the basic introduction of the wireless networks, consisting the node architecture, communication architecture of WHN, right, and layering concept. And thereafter, we will go for the advanced applications, and then securities comes in picture, right? So all the contents which I have taken are well referenced and cited, okay? So the basic objective of this talk is to be aware about the wireless sensor networks, design issue and structure challenges of wireless sensor network, understand communication structure of wireless sensor network, to analyze the protocol stack. If the time allow, we will cover this. But straightway we will jump for the security requirements and taxonomy of security attacks. If time allow, we will cover the data gathering and aggregation technique, but this is again the use area, and in fact it is time consuming, but we will cover the overview and of most of the things. We will try to cover the overview and research challenges. So thereafter, what are the simulations and emulation tools are available for the wireless sensor network, right? So this is very much important because you are not going to purchase all the sensors and deploy all of a sudden without considering the scalability, without considering the security. So many sensitivities analysis issues are there, right? So it would be better, why not use some validated and reliable simulations tools before go for the real time work. It would be better if you go for the real time work but real-time deployment of wireless sensor network. But it is, only the experts having the expertise, having the experience, and it is the, risky things, and investment also requires huge investment for the real-time deployment. So most of the researchers, they use the simulations tools at a starting phase, and thereafter they move for the real-time implementation, right? So this is the basic objective of my talk, and these are the outlines which I have listed. Overview of the wireless sensor networks, structure of wireless sensor nodes, communication structure, what are the security requirements, what are the taxonomy of attacks in the wireless sensor networks, security challenges, simulations tools, data aggregations, and research directions and conclusion, right? So these are the outlines. Let us start with the overview of wireless sensor networks. Wireless sensor network, consists of the several small nodes which are deployed in the sensor field. Sensor field means the area where the sensors are, deployed, or in densely or in scattered way, right? So there, the wireless sensor network, in fact, consists of so many small devices, like we are discussing, right? So it is a group of specialized sensors and transducers, right? So WSN, which is having the very specialized sensors, maybe for sensing the temperatures, moistures, movement, tracking object, right? And the transducer part also. So having the capacity of communication infrastructure, these nodes intend to monitor and record the condition at very diverse locations, right? Where the people, even sometimes sensors deployed, and where the people is not going and visit the place, like a very terrestrial area, mountain area, right? Fire, volcanic, underwater sensor network, the place where the people just deploy by some mechanism, deploy the sensors using some mechanism, and monitors the activities, monitors the environment, right? So deployment, several devices equipped with the sensors that performs the collaborative measurement process. So the entire, the sensor networks work based on the collaborative measurement. So each of the intermediate nodes must collaborate, and must assist, should must help to forward the packets to the sync node or to the next node, so that the next node or sync node can process the data, right? So the entire ad hoc networks, wireless sensor networks is the part of the ad hoc networks, because sometimes it is deploy on ad hoc basis, temporary basis, and sometimes the fixed the deployment is there. But again, there are so many issues like battery power, okay, and movement, mobility, and many things are there that you can see here, right? So self-configured wireless networks, because topology changes if you are deploying the the dynamic scenario kind of wireless sensor networks, then self configurations should be there, because of the monitoring the physical environmental conditions, movement, and right. So wireless sensor nodes should be self configured, right? And each wireless sensor node cooperatively pass their data through the network to the main location. In main location is nothing but it is the sync node that we will be discussing in the next figure, right? So sync node, where the entire data, collected data, to be observed and analyzed. At the sync node, the aggregation is done. So sync node play the very important role to collect the data from the various sensors, maybe the cluster base, maybe the hierarchy base, layered base. Okay, so wireless sensor node contains the hundreds and thousands of nodes. It all depends the kind of the applications that basically we are targeting to make, right? So based on that, the scalability is there. Based on that, the deployment of the sensor nodes and each sensor nodes can communicate, right? So communicate among themselves. If there are so many mechanisms, huge research area is there. If sensor node is not having the battery power, you can make the another node as a cluster, so that the next node can the transmit the data and link with the cluster node. So uh, wireless sensor networks enables a new applications requires non-conventional paradigm, because whatever the protocol has been designed for the wired will not work here for the wireless. Okay, you must have to see the paradigm change from the wire to wireless, and then you need to design the protocols. Okay, and there are when you are designing the protocol, there are so many constraint are there, right? Energy is the one constant, memory is the another constant, temperature is the another constant, right? The physical protection of the sensor should be the another. I think huge constraint and research complexity are there. So owing to all these requirements, like low device complexity together with low energy consumptions, okay, and long network lifetime, because see, once you are having the energy, very less energy dependency on the battery, obviously the network lifetime will be less, right? So ultimately you need to increase the network lifetime also. So many things that you need to reduce, okay, overheads, then and then your network lifetime will increase. And proper balancing between the communications, signals, data processing capabilities must be found, right? So this motivates the huge efforts in research activities and standardization process and industrial investment. Uh, so many, investment happening for last by the industry people in the wireless sensor networks for the military applications, for healthcare applications, for the environmental applications, right, for agriculture sectors. So huge work is going on since last years, in fact, since last decades. Okay, so these are the applications. Now we have covered the basic concept of the wireless sensor networks. Next is the applications, and there are lots of advancement in the applications are there, right? So applications of the wireless sensor network, it gains the considerable popularity due to the flexibility in solving the problems, and several applications are there, a huge potential to change the life, day-to-day life of even the human being, where the body personal body area networks are there, where the sensors are embedded in the body to monitor the heartbeat, to monitor the blood sugars, to monitor movement, so many things that you can actually biological monitor you can have, right? So use area, huge applications are there, wireless sensor network. Few of them we will discuss here. Wireless sensor networks have successfully applied in various applications domains. Military applications is the one, and military applications wireless sensor network is very sensitive, because the uh, one party is the military commandant, another one is the enemy. You cannot send your soldier to the particular that direction, otherwise the enemy, they will catch and they damage, right? So the sensors will be there. Again, the sensors should also be protected sensors. So military applications is the very a hot area where the wireless sensor networks is happening. And the communications networking always evolved from the defense, from the military. Even if you see the history of the networks, it is started with the DARPANET, and right. So you can see that the military applications where the wireless sensor networks play a very important role for the controlling, for the communications, for the computing, to send the intelligence information, battlefield surveillance, surveillance of the enemy, surveillance of the movement of the vehicles, right? you can locate the enemy or ascertain strategic features and targeted systems, right? So military applications is the one part, because see, when you have started working or you want to start research area, research in wireless sensor network, very first questions, what kind of applications you are targeting for deployment of your wireless sensor network. So you should be very specific about choosing the applications, right? Next is the area monitoring. So area monitoring, where the sensor nodes are deployed over the region where some phenomenon is to be monitored. Maybe you can monitor like heat, pressure, temperature, and the event is reported to one of the base stations, which then takes appropriate actions. Transportation, in fact, like real-time traffic information that you can monitor by putting the, sensors roadside, right? So vehicular ad hoc network is there, right? So you can put the sensors, small sensors to monitor, the vehicles. Okay, so but vehicular ad hoc network is again, the sensor networks where the roadside information you can collect. You can collect the traffic information and put it on the server, and you can analyze the data. See, data play a very important role, and all these data will be generated from these kind of server applications. So big data also comes in the picture, IoT comes in the pictures. Okay, so these are the advancement. Now wireless sensor network is not limited to the area monitoring and transportation. Wireless sensor networks is used for the IoT. Wireless in use sensor network is used for the IoT based, smart city, right? Healthcare system, use area. In fact, advancement, so many advancement is done for last many years for deployment of the wireless sensor networks to monitor the object, to monitor the environment, to right. So these are the third applications that we talk. Fourth is the health applications. So health applications is very much important. You can, diagnose the people, diagnose the patient, diagnose the heartbeat. Okay, so telemonitoring of human physiological data, and tracking and monitoring the doctors, patient, nurse. They can, use this kind of application. Environment sensing is one of the another, area where the sensor networks can be deployed, and to earth sensors, and maybe, I mean, the sensor networks you can use to predict the volcanoes, sense the volcanoes, sense the ocean activities, glaciers, like Himalayan terrestrial area. You can deploy the sensors, small sensors, and you can monitor the object, like our Indian soldiers. Every year we are losing our beloved Indian soldiers. So obviously the government of India, they have used the kind of the sensor network for tracking, right? So they lots of projects are going on, even in the hilly area, glaciers, forest, right? So for you can use for the air pollution monitoring, you can use for the object monitoring, like soldiers monitor. You can, if something wrong happens, right? And in the glaciers, right? And you can track the object where it is exactly, you can track the location. Okay, but at the same time, tracking the sensors is also should be tricky, because where is the sensor? What about the location? Where it is? So localization issue of the sensor itself is a big challenge. Okay, so node localization, sensor localization is the another challenge, is even to know where exactly the node location is there, right? So forest fires detection you can use in the environmental sensing. Greenhouse monitoring, very useful area where you can, use the sensors to monitor your greenhouse development of your, agriculture product. Okay, So landsliding detection is another area where you can use. So these all are the area where we talk about the environmental sensing. IoT, lots of in fact work is going using the IoT, okay, and it is the use area because everything is connected with the device, and high bandwidth is required. So IoT paradigm change everything about the wireless sensor network, right? And many aspects of the life, such as connected homes, connected cities, connected office, connected cars, connected roads, and roadside to device like vehicular ad hoc networks that we talk, everything should be interconnected. So a wireless sensor network recognize the enables of the IoT. Industrial monitoring, you can monitor the industry activity. Okay, so condition-based maintenance, you can so engineers, those who are working in particular like in this industry, maybe the boiler company where the boiler temperature you can monitor, because the young boy, they are working for monitoring of the boiler, okay, 50-degree temperature. You can simply put a one sensor and you monitor, sense the temperature from the boiler area, and thereafter send it to the sync node, and you can monitor the temperature. So this is another industrial monitoring you can consider, right? Structural monitoring is also there, like lots of civil work happening even in India. Okay, so because India is having the huge potential for the infrastructure development, and bridges, flyover, embankment, tunnels, everything is under constructions, even starting from Jammu Kashmir to the Tamil Nadu, right? So this is the costly affairs, but there also you can use the kind of the wireless sensor networks to monitor the movement within the building, within the bridges, within the flyover. Agriculture sector is the huge area where you can target for the wireless sensor network. So smart agriculture, intelligent agriculture system, okay, smart irrigation automations enables, and this will help you for the cost optimization and cost of the resources, the wasting of the resources. So you can conceptualize many of the applications related to the agriculture sector, right? This is the another PPT which I have taken from Dr. Sudeep Misra, IIT Kharagpur, India. Okay, so you can see that advancement of the wireless sensor networks, like wireless sensor networks is used even for the social sensing based on cycle management for monitoring rare events. Okay, so this is the another area where you can use, where the social sensing, even if you are using the Facebook or WhatsApp or any other kind of social networks, you can uh, map with your social networking by using some kind of WSN, and send it data to the um, uh, sync node, right? So this is the another area. Fire monitoring and alarm system, right? Many you will be finding the many of the research paper related to the fire monitoring and alarm system, right? So if you see the South African country, many times what happens, a forest, they get the fired and they engulf entire forest, they engulf within half an hour, and so many days fire fire brigade is there, but nothing happens, right? Who will be going into the forest and stop the fire, right? So this is the another issue. There you can deploy the wireless sensor networks to fire monitoring and alarm system, right? So coal mining area, this is the paper you can refer, that where the entire work has been done for the coal mining, like in Jharkhand and some parts of Odisha, they are having the huge coal. Okay, so uh, these actually paper, this kind of the sensor networks, deploy over there, and they monitor temperature sensors by using the coal peeler, right? So this is another wildlife detection using sensor networks you can consider, like Dr. Prabhat Ranjan. He is now, the um, D.Y. Patil Vice Chancellor, Pune, Vice Chancellor of D.Y. Patil International. He worked in this area for the wildlife detection using sensor networks. So even you can find Dr. Sudeep Musra, IIT Kharagpur. He is having lots of work along with his PhD and master PG students. You can find Dr. Prabhat Ranjan work is also over there. Security, in fact, my PhD students, they work in the security. Right. So wormhole attack and DOS attack. Right. So this is the another area, again, a wireless body area network, WBAN, where you can use the small sensor based on the Bluetooth or Zigbee protocols, right? And you can monitor the wireless body area network. So this is we discussed already. You can surface, like the electromagnet, these things, blood pressures, we already have discussed this, right? So these all are the advancement that you can see. Here you can agriculture intrusion detection that we already have talked. There is a huge potentiality if you are interested to carry out your research work in agriculture system, right? And from there the whole data will be generated, and based on, if someone want to work on the data analytics, so the another area where you can focus, but for that you must have some the data, right? So this is a smart city use area where you can monitor, by putting the sensors you can monitor your the movement of the buses or garbage collection, noisy points, temperature, CO2 level, okay, many other things. Even you can monitor your entire buildings. Municipal corporation will deploy this kind of sensors to monitor the each of the building, and right. So huge area you can actually make a prototype, and you can implement or some applications based on the wireless sensor networks. But before that, you need to refer research work which has already been done in this particular area for these particular applications, right? So lots of advancement is happening in wireless sensor networks. Underwater sensor network is the another area. So one of my PhD students is working in underwater sensor network, but she is working at the cross layer, okay, cross layer of the data link layer and network layer, okay, for the energy conservation. So this is the another area, underwater sensor networks, where you can focus. Okay, so these network consist of the several sensors, nodes, and vehicles deployed underwater, right? Like Ganga Swachh Abhiyan. So many, underwater sensor networks might have deployed to monitor the quality of the water, right? So autonomous underwater vehicles are used for gathering data from these sensors, and huge challenges are there, right? I mean, challenges, the first thing is mobility, then radiations, then velocity. So change of the underwater communication is a long propagation delay. So obviously, because propagation delays, overroads will be there, data packet delivery will become less. Okay, so and bandwidth is the another issue. There is a possibility that sensors become failure. How will we repair that? How you will be making the sensor node on and off in the underwater sensor? These all are the challenges where you can focus, and lots of research work is going in this area, right? So wireless underwater sensor networks, where you can environment, you can monitor quality of the water, you can monitor the earthquake and landslide monitoring, you can use sports field maintenance, you can precision these things, right? So many things actually are there in advancement of wireless sensor networks. So these all are the applications, right? So first part we have covered about the introduction part. Second part we have covered the applications, right? Now the third part is related to the design issue of the wireless sensor networks. All of you are with me. I'm connected, if I'm not wrong.
Yes, sir.
Yes, sir.
Okay, right. So I'm sending my hello packet to just to check whether you are connected with this network or not, right? So yeah, thank you for confirmation. So third part, we are going to focus on design issue of the wireless sensor networks, right? So when you are designing the WSN, there are lots of issues, and very first issues, the energy, because all the sensor nodes are having the limited energy because they are having battery enabled nodes, unless and until you put it some solar kind of energy generation, right? So there is an advancement in development of the wireless sensor nodes where they actually generate the energy through solar kind of things, and a battery, chargeable battery, you cannot put over there, right? Because you are not going to in the enemy part of in the military applications where you can go and charge. Okay, so this is the another challenge, and again, if you see the underwater sensor network, the again the only solution is the battery enabled energy should be there, right? So through the battery only, because of the underwater, right? So limited, usually non-renewable energy supply of the, so uh, mm, usually non-renewable, but I'm talking about that nowadays so many advanced things happening to generate the renewable energy and provide the constant energy to the sensor node. So this is another area where you can focus to the research, right? And this will be the great contribution. And maximize the lifetime of the network. The protocols need to be designed from the beginning with the objective of efficient management of the energy resource, right? So a different way that you need to think, innovative way. Fault tolerance, in any conditions, your data should be secure, your node should be there, right? So this is another design issue. Like sensor node can fail due to the hardware problems or physical damage or by exhausting their energy supply. Node failures to be much higher than the one normally considered in wired or infrastructure based, right? So node failure is having the higher chance when you are using the wireless. Okay, and the protocols deployed in sensor networks is totally different than the wired kind of protocols, right? So it is detect these failures as soon as possible. So you have to design the protocol that has to detect if something went wrong and some nodes failure, and these should be traced as soon as possible, right? Because delay you cannot afford. Okay, 300 400 milliseconds is the affordable delay. Okay, you cannot afford delay in the network more than 400 milliseconds. So robust enough to handle the relatively large number of failure while maintaining the overall functionality. So this is the another design issue, fault tolerance. Scalability is always there, depends upon the size of your wireless sensor networks. Okay, where you want to make the sensor field of the 1,000 nodes or 100 nodes, but again it all depends upon your requirement. And deployment density is also variable. Collecting high resolution data, the node density might reach the level where a node has several thousand numbers in the transmission range. Transmission range is again the issue. Okay, like a node with the transmission range maybe the 20-meter 30-meter kind of thing. How to enhance the transmission range is the another because is another research challenge, because you are not going to connect with the 3G 4G or 5G. Maybe in the future 5G networks are there, maybe you can connect, but it is very difficult, right? So transmission range, like if the node is connected with the one node to the straightway 20 meters, right? Another node is there, so straightway direct range is there, right? But if you want to send the 100-meter range node, so in that case the multi-hop kind of routing algorithms kind of protocols would be there, and multi-hop protocols are there. In fact, multi-hop clustering algorithms are there, like so there to reach the 100 meters or 120 meters, okay, you have to travel hop by hop, right? So this is the another scalability is the another research area where you can focus, right? So the protocols deployed in the such a network need to be scalable to these levels and to be maintain adequate performance. Performance you should not compromise, right? Because ultimately the major network performance are the reduce the overheads, packet delivery 100%, okay, reduce the delay, routing load should be minimized, okay, throughput must be there, and throughput and packet delivery ratio straightway they map, okay. So these are the network performance parameters that you can consider. Production cost always for electrical and DC people, you can more focus on this to make a cheap wireless sensor nodes. Okay, so because many deployment models consider the sensor nodes to be disposable device, it is after sometimes all the nodes in the wireless sensor networks is having the life. After sometimes they will die. Okay, so because it is disposable devices, so sensor network can compete with the traditional information gathering approaches only if the individual sensor nodes can produce the very cheap. Okay, so costing point of view, you need to also focus, right? Hardware constraint is always there in design issue whenever you consider. So in fact, electrical AC people, again you can focus here, like every sensor node to have the sensing unit, a processing unit, a transmission unit, and power supply. These are the 4 units are mandatory to have every sensor nodes, right? Optionally you can have some other features, but these are the mandatory parts. So the nodes may have the several built-in sensors or additional devices, okay, include the transducers, localization system. You can GPS kind of things you can track where is the sensor. So localization system monitoring you can also actually inbuilt with these kind of nodes, okay, so that you can aware about the node locations, you can aware about the routing. This will very much helpful for the routing, okay. So this is the another research challenges, and you can first see what are the work has been done particularly for the location disclosure, and many attacks happening, whatever we are talking here, huge scope for the attacking but now design, we are going to touch the right. Every additional functionality comes with additional cost. You are aware whatever you will be including, whether it is the localization, transducers, or any additional features that you are including, obviously it will be the costing. It will be the costing, and increase the power consumption and physical size of the node also. Node should be limited. I mean, you cannot develop the sensor node having the big size. So this is the another challenge, and everything you should have to see that the balance is there, balance against the costing and low power needs. Okay, otherwise if your power consumption is there, right, delay will be there, lots of competitions you need to reduce. Okay, so this is the hardware constraint point of view. Sensor network topology or structure, you are aware there are 2 kind of sensor network topology. You can see the kind of the network we talk, the static networks and dynamic networks, right? So in dynamic networks, the network topology will change. The structure will not have the fix, right? A structure will be fixed in the static network. But there are several applications where the static wireless sensor networks is not useful. So you need to design the dynamic kind of, the wireless sensor network. So WHN evolve in many aspects, and they continue to be in a network with constant resource in terms of the energy, computing power, memory, communication capabilities, right? Of these constant energy consumption is the paramount importance. So use importance is given in the energy in wireless sensor networks, right? And this is demonstrated by the large number of algorithms, technique, protocols that have been developed to save the energy. Many researchers, they have, they have worked to reduce the energy, okay, and thereby extend the lifetime of the network. If you are able to reduce even the 2%, 3%, there is a great contribution, right? And you can claim that this is the your contribution, which straight away you can compare with the previous work of some researchers, and this will help you for again the enhance the network lifetime, right? So topology maintenance is one of the most important issues, and researchers, they reduce the energy consumption. Transmission media, with lots of ISM bands, industry, scientific and medical bands are there, and you can see like so many transmission media are there, through like infrared technology, right? So many kind of Bluetooth, Zigbee, right? So transmission media there, right? Power consumptions, so there is a huge challenge of the power consumptions, challenge of the sensor networks, right? So always power is the issue, energy is the issue, and data compression. If you apply the data aggregations, if you apply the data compression, sending the data from one place to the another place, if you are applying the computations, complexity, right? Obviously it will be it is trading in between these issues to the energy. So there is always trade-off in between the energy and your computations power, compression algorithm, sending the data aggregation, all these things, but uses additional energy for computation or filtering. This is the another area where you can focus design issue. This is the structure. The fourth part of my talk is related to the structure of the wireless sensor network. So we know that the sensor networks are having the four mandatory components: the sensing unit, processing unit, transceivers, and the power unit, right? And has the application dependent additional components such as location finding, we talk power generation and mobilizer. Like when we talk about generating the power through solar, okay, generating the power through nuclear, but I don't know, I mean, what advancement work has been done in this area. Again, I need to explore it, right? So sensing units are usually composed of the two subunits, sensors and analog. So digital converters, ADC is there. So you can see this is the structure. This is the basic structure of the wireless sensor nodes. This part you can see like this is the sensing node. So sensing unit is there, processing unit is there, transmission unit is there, and power unit is there, right? These are the four mandatory. So sensing unit will sense the data, okay, convert it this thing, and they send it to the processors, microprocessor, microcontroller are there, CPU is there, storage area is there. So these are the part of the processing unit. So each of the sensor nodes is having this one. Thereafter the transceiver is there, the communication medium is there, right? And thereafter therefore the energy to keep your node live, the power unit is there. These are the mandatory. Apart from this, if you want to make your node movement, then the mobilizer you can add, but this is not mandatory. These are the optional part. Position finding system, like localization issues are there. If you want to track your node where is exact location this node, sometimes it is required. Okay, so for that purpose you can add the additional feature of the position finding system. So this you can see, this is the one sensor field where these all are the small sensor nodes, and they establish the communication. To establish the communication, the hybrid protocol you use, and you are aware about the TCP and OSI layer. But TCP and OSI layer is used, TCP in fact is used for the real time, and OSI is used for the teaching purpose, we can say. And always we are asking 7 marks question, what is the difference between TCP IP protocol and OSI protocols. But please remember, in the wireless sensor networks, the hybrid kind of protocols is used. Okay, so where the top layer applications layer are there, transport layer is there, network layer is there, data link layer is there, physical link layer is there, right? So all these layering concept always be there, because ultimately you have to generate the data from the far away deployed sensors, send it to the sync node or base stations, and then interact with the internet or some communication media. Okay, and thereafter it goes to the user. So obviously, in this scenario, the TCP/IP protocols or hybrid protocols apply, right? And please remember, my dear students and faculty members, all these protocols layer which I talk, application layer, then transport layers, and then networks layers, and data link layer and physical layer, all layers, they require the security, right? So let us now jump. I think someone has sent some message, so let me see. Okay, right. So this is okay. I mean, everyone, am I audible?
Yes, yes,
Just
yes.
Yes,
yes,
sir. Yes, sir. You're audible.
Yes, sir.
right. So now we are moving towards the security part. Okay, so because so many things are there in the structure, right? We have discussed this figure, and I always used to tell that one figure is equal to 1,000 words. So one figure representation is having the 1,000. So we are straight with skipping all these parts. We are not going to these things cover. Data aggregation, taxonomy, leech protocol is a very popular, right? And many researchers, leech protocol is used for the data aggregation, and leech protocol has been extended by many researchers, and they have given some improvement. Okay, and they claim their own research papers and patent, like leech B, leech E, leech H, TL leech, leech me, leech C, leech F, leech M, multi-hop leech, right? So these are the protocols again for the data aggregation to reduce the energy. So you can refer all these leech protocols, but all of these 7 to 8 leech announcement paper base is only the leech protocol, right? So use area is there, you can contribute something here, right? So data aggregations we are not going to cover here. This is a very interesting you can see that the wireless sensor networks and IoT, once it is combined, there is a 90% of the world data will be related through the internet, and these data, 1.1 billion data points generated by sensor daily. Okay, and this is the information which I have taken from the Cisco and Cisco website, right? So 1,000 gigabytes you should see data generated by oil refinery. Okay, so 2.5 billion gigabytes. So people now they are talking about the next oil is the data, right? So data is the next oil and next assets. So 2.5 billion gigabytes data generated by worldwide daily, and 500 gigabytes data generated by an offshore oil rig weekly. 10,000 gigabytes data generated by jet engine every 30 minutes. Okay, so 90% of the world data that you can see, and this has been created in the last 2 years, and this is the data, this is the survey data during the 2014. So even the 7 years old, right? So once the data is there, now the big data concept come in the picture. Those who are interested in the data analytics, data scientist, you can work here, but you can work only once you have the data generated by the sensors, right? So you can see here that these all are the sensors. Okay, so all the nodes component, here it is the sync node. This is maybe the cluster node or layered architecture node, right? They generate the data, they send it to the source node, sync node base station. Data aggregation will be done like leech protocols and other protocols. After these data aggregations, data aggregation is means remove the redundancy. So many technique are there, right? So again, when you are remove the duplicacy or redundancy, ultimately unnecessary computations you are going to stop, and this will help you, for even the energy conservation, right? It will enhance the network lifetime. So data aggregations play a very important role here, right? After the data aggregation, it will be stored in the main storage area. So this can be the main storage area where the some a huge data will be there, right? And thereafter lots of technologies are now people they are talking, like big data platforms, Hadoop, MapReduce, HBase, and to make the data useful. So many analytics work is going on this query or report related data. Here the big data, thereafter the comes, I mean, if you want to make it intelligent, machine learning, supervised, unsupervised kind of things are there, right? So this is the big data analytics in wireless sensor network. So this is the kind of things. Now we are moving towards the security parts. Next we have the 20 minutes time, and we try to cover most of the security parts, right? So many of the applications that we know, whether it is for the homeland security, environment monitoring, underwater sensor networks, or fire, forest area, or body area network, these all are the sensitive applications, right? And use security is required to make the data transmission is secure. Right. So this is the huge area, but security will be done once you establish the network. Right. So earlier people they talk about why not establish the reliable communication. Right. Why not establish the network with some validated data transmission. Thereafter the security. Right. So this could be deployed in uncontrolled environment. You are deploying the wireless sensor networks where you are having no control, no human interference will be there. Like people is not going to enter in the enemy area. People is not going to enter in the underwater always. People is not going to enter and interfere in coal mining. People are not going to enter in the volcanic area, cyclone area, right? There the sensor nodes will play the role. Okay, so wireless communication make possible the eavesdropping, and wireless communications they have the possible scope where the eavesdropping can be done. Anyone can enter, intrude in the network, and can modify your packets. Now these things has to be secure, right? So always monitor their surrounding. You need to monitor the surrounding also, so it is easy to infer the unwanted information results in the privacy violations. Okay. And wireless sensor networks are vulnerable to security attacks due to the broadcast nature. Okay, because sensor nodes they broadcast to their neighbors. Okay, and their neighbors or intermediate nodes broadcast to their neighbor, because the entire wireless sensor network works based on the multi-hop networking, right? So secure transmission of the various type of information over the networks. Several cryptographic and steganographic and other techniques are used. But again, the old cryptographic mechanism, AES, TES, these kind of algorithms you can't apply. Lightweight cryptography mechanism you apply. Otherwise, computations, because cryptographic is based on the computations, and computations, if you are having the complex algorithms, it takes the energy, right? It takes the time. So which is you cannot have, afford much here. So whatever the cryptographic algorithm developed for the wired will not support largely for the wireless sensor networks. Okay. And you are aware these cryptographic and steganographic techniques, right? Wireless sensor networks have an additional vulnerabilities because nodes are always placed in the hostile. So always in the enemy area, you are basically putting your sensor nodes. So always the dangerous environment is there where they are not physically safe. Okay, so you have to make your physical, you have to make your protocol safe, you have to make the data transmission communication channel safe, right? So there is a huge area for the high security in wireless sensor networks. WSN security requirements, like these are the requirements, and you know that the security requirements like confidentiality. If I am talking to you, my voice should reach to you only. Okay. Integrity, if whatever I am talking to you, the same message should be delivered to you. This is the integrity. Freshness, if I'm talking right now 10 o'clock 40 minutes 30 seconds, within a fraction of second that my voice should be delivered to you. I mean, the old data should not be delivered, right? So still data should not be delivered. So many things, authentication is there to make the only the authenticated nodes can transmit the data, right? Non-repetitions is there, like you cannot deny after sending the data that you have not sent the data, and the receiver, they cannot deny that they have not received the data, right? So this is the kind of the non-repetition, forward and backward secrecy that you need to maintain, because each of the sync node and each of the sensor nodes, they communicate, right? So the secrecy, the security has to be maintained in between these things. So these are the basic requirements. And next requirement is the survivability. Your wireless network should be reliable, should be available 24/7, and should be energy efficient. Okay, so these are the major requirements of the wireless sensor network, right? And this is the place where the security plays a very important role. So we talked about the data confidentiality. Whatever the data that you are transmitting in the node should be delivered to the intended destination only. It should not be delivered to someone else, right? So sensor network should not leak the sense or reading to its neighbors. In many application, nodes communicate high sensitive data, like military applications. Okay, soldiers, they are communicating with their commanders, they are communicating with their defense minister, right? So the whole, I mean, huge data is transmitting, but all these highly secured and confidential data is transmitting, right? So data confidentiality is must be there. And because the public sensor information, such as sensor identities, public keys, should also be encrypted. And once you confidentiality you can achieve by using the encryption, but encryptions, lightweight encryptions, you can use it, right? Next is integrity. We have talked about in between transmission, your data should not be disturbed or modified. The same data should be delivered from the sensing node to the sync node, or sync node to the base node to the internet and end users, right? So this doesn't mean that the data is safe. The adversary attackers can change the data so as to send the sensor nodes. If the data is changed, commander is sending some information and soldier is receiving something else, right? So this integrity must to be maintained, right? Freshness data must be there. Need to ensure that the data is latest. Data is not stale. Okay, each of the message that you are transmitting should be fresh. So data freshness suggests that the data is very much recent, and it ensures that no old messages have been replayed, right? So old data should not be replayed, or old data should not be forwarded. Timer is on, right? So timer play a very important role in entire network, please remember. So this requirement is especially important when there are shared key strategy for message communication, where a potential adversary can launch the replay kind of attacks, right? So replay, I mean the stale data will be sent again and again, and the whole network will be busy. So this is the another kind of the attack. Okay, so you can data freshness, you can use it. Okay, you by using the time is specific counter, you can make it on. Okay, so this is the basic mechanism to check your data freshness. Sequence number is also there. Each of the data, at the TCP IP, they are making the sequencing each of that. So it's a sequence number is the another things that you can check for the freshness. Availability. Okay, your network should be available 24/7. It should not happen that if some DOS attack is happening, your entire network is down, right? Your network should be so robust that it should protect from the kind of the denial of service attack. And denial of service attack is not I mean many kind of denial of service attack. Okay, like making your system jam, making sending the so many packets which is not having the capacity of the networks, right? So DOS is the another research area where you can more focus for the denial of service attacks. So some mechanism make use of the additional communication among nodes. Other propose of the central access control system should be there to monitor the availability, to monitor the movement, to monitor the the capacity of the data transmitted from the particular node, and they ensures the successful delivery of the every message to its recipients. Authentication, every node should be authenticated. Unauthenticated entry should not be there. Okay, so the authentication is necessary in this case. Okay, access control, once the node is there in the network, what kind of privileges that you are assigning. So give the legitimate participants means to detect the message coming from the external source or it is from the internal. Non-repetition we have talked, forward and backward we have discussed. Self-organizing is the another parts where we have discussed at the starting of my lecture that wireless sensor network is self-organizing because of so many so features of embedded feature of the WSN, right? Because of the dynamic nature of the wireless sensor networks, and that makes the sometime impossible to deploy any pre-installed shared key. So if you have the pre-installed shared key mechanism among the nodes or the base stations, right, this will not work here, right? So number of key pre-distribution scheme have been proposed in the context, but many researchers, they are working still to enhance this work, right? So applications of public key cryptographic technique and efficient technique for key distribution, this is a very much important area. So nodes in wireless sensor network self-organize among themselves, not only for the multi-hop routing, but also to carry out the key management. Okay, so self-organizing is not limited to only for the movement of or transmission of the data from one hop to the another hop, right? Uh, but also to carry out the exchange, key exchange in kind of the things, right? So management and developing the trust in between the two parties. Secure localization, I mean, sensor nodes should be so secure that their localization should not be disclosed. Otherwise, people, they will, I mean, enemy will catch and, destroy the wireless sensor networks nodes and the network nodes, and so wireless sensor network is down, right? So in many situations, it becomes the necessary to accurately and automatically locate each sensor node in the wireless sensor. For example, wireless sensor network designed to locate the faults requires so accurate location of the sensors nodes to identify the faults, right? Location information is not secured properly, so this is the huge area and for the research. Otherwise, potential attackers, they can manipulate and provide the false location, and once they provide the false locations, and then the whole reporting will going into that direction particular node only, right? So this is the another requirement. Time synchronization is there. This play a very important role. Timer. So most of the application in sensor networks requires the time synchronization. Security mechanism for wireless sensor networks should be time synchronized, and they collaborate. Wireless sensor networks may require the synchronization among the group of the sensors. So synchronization is required along with that specified time, and several researchers propose the set of secure synchronization. You can explore about the secure of the synchronization protocols, right? So many papers you will be finding over there. Now taxonomy, this is the last things that we can discuss. Taxonomy of the attacks. Attacks usually can happen based on the capability of the attackers, based on the information in the transit from the sync node to the sensor nodes, or vice versa, from the sensor node to the sync node or to the data aggregation nodes, right? Protocol stack is there, right? So there are three things that we can consider. If you consider the capability point of view, so outsider and insider attacks are there, passive and active attacks are there, mode class and laptop class attacks are there. So these are the three kinds of 3 multiplied by 2, 6 kind of attacks based on the capability, right? Outsider insider attacks always from the penetration point of view, whether it is the part of the network or outside the part of the network, how they entered in the networks without having the authentication. So because of the spoof, they will take the identity of one node and they make fool to the other node that they are the genuine node. So there are so many ways that attackers they work, right? So this is the outsider and insider attacks. Passive and active attacks, again, point of view, the how the attack is done, right? So passive and active. Passive attack is very dangerous than active attacks, right? Active attacks, you can detect it, you can prevent it, but passive attack is very difficult because they are working, in eavesdropping mode. They are not disturbing any your message, they are just listening. So detecting the kind of the passive attack is very difficult. So they only monitors, they will not disturb your channels. Once they monitor, after 6 months, after 2 months, they will disturb your entire network, right? But by the time 6 months and 4 months, they will observe everything. That is the reason, because they are not destroying, they are not disturbing your communication. So it is very difficult to detect the kind of the passive attacks, right? So only monitors the communication channels, they threatens and confidentiality of the data. Actives attacks, always they destroy, they delete, they modify your transmission. So integrity and confidentiality issues are there, right? Authentications, they sometimes take the identity of someone else and they try to enter into the networks, right? And there are so many mechanism that people they are intruding in your wireless sensor networks, right? So this is the second part. The third is the mode class attack and laptop class attack. Mode is the one kind of sensor device, small device sensors. So mode class attacks has the access to few nodes with similar capabilities. But if you are having the kind of the laptop class attack, they are having the high power, high advantage of taking the legitimate nodes, like because of they are having the battery power, more capable CPU and high power antenna. So these are the two other kind of attacks are there. Then based on the attacks on information of in transit, so transit is from sending the data, so interruption, interception, you can interrupt the message, you can intercept in the highly secured area, you can enter, attacker can enter and intercept your message. they can modify the data, they can fabricate, they can generate some new kind of attacks, right? So these are the attacks based on the some transit, right? So this is the things that I have written here. Now, based on the protocol, this is the last part. Based on the protocol, these you can see that every protocol layers, they requires the security, please remember, right? So you are aware about the wireless sensor network architecture, you are aware now about protocol stack, combining the awareness and power, right? So you can see here, like protocol stack, the task management is there, mobility management for the movement, what kind of work has been given, what kind of power energy plane is there, right? So these are the three. Other than these, application layer, transport layer, network layer, data link layer, and physical layer, and each of the layer, they require the security. What kind of security? What kind of attacks are happening? So let us take it from the physical layer. Okay, physical layer having the kind of the device tampering. Okay, they disturb, they tamper your node device, they make your system jamming, right? Eavesdropping. So there are many solutions are also there. You can prevent these kind of attacks by using the access restrictions. You can use the encryption algorithms, right? So huge work has happened, and lots of research papers are there. You can trace it, right? So physical layer attacks are there. Like this jamming is another, the kind of the DOS attack itself. So you can see that these attacker, they are generated the huge informations, and they are sending the unnecessary information to jam the entire, the network by sending through the radio frequency. Then data link layer attacks always, like data link layer is responsible for the framing, collision, error check, okay, unchecking the unfairness, control flow. Okay, so many things are there. So here you can see the kind of this kind of attacks, right? So misbehavior detection, identity protection, by using this mechanism, these kind of attacks, collision avoidance can be done, unfairness you can check, exhaustions you can actually prevent, right? Then collision like this is the collision, right? Same data is transmitted by several nodes, right? So because they have altered the transmission octets to disrupt the packets. So checksum is there that you can use. Okay, network layer, lots of research work is going on. I work in the network layer, right? So and my PhD students, they also work in, one PhD student, they work in the cross layer network, and one PhD student, they have completed their PhD, but they work especially for the wormhole attack, right? You can find his paper, a joint paper we have. You can search it from the Google Research Scholar or the Scopus, you will be finding. So network layer attacks, false routing, spoofing is there, black hole attack is there. I mean, they will tell that they are the genuine nodes, and the whole nodes, they will become full and sending the whole packets like in one area, and they are not forwarding that packets, right? So the entire black hole kind of thing, sinkhole is there, wormhole is there, right? There in wormhole, they prepare the tunnel, high bandwidth tunnel from one node to the another node, and the whole things has been happening in between two. Sybil attack is there, multiple identity representation, right? Selective forwarding is there, hello flag, make the entire. Now these kind of network attack are there, where you can work more focus on these for prevention mechanism. So there are various solutions available, like routing access, you can restrictions you can give, false routing information detection is there, network intrusion detection in IDS system is there, right? So many things are there in the networks. I will send this PPT, right? So network layer, you can see the sync nodes. The adversary attracts the surrounding nodes with unfaithful routing information. Wormhole is there. You can see that these two attackers, they prepare the tunnel, and the whole network has been diverted in between these two peoples, right? So the entire traffic. The adversary tunnels the traffic receive in the part of the network to the another, right? This is the Sybil attack, like a single node represent the multiple identity. These attackers, they are telling that they are having the identity of A, B, D, E, N, C, and right. So they are actually the kind of the Sybil attacks. So selective forwardings is another, like in multi-hop networks. We have discussed multi-hop networks because wireless sensor network work based on the multi-hop. The reason is that every node is having the range 20 meter, 30 meter, 40 meter. So to reach the up to the some certain distance, you must have to go hop by hop. Okay. So for the message communication, all the nodes need to forward the message accurately, and an attacker may compare a node in such a way that it selectively forwards some message and drops the other, right? So this is the kind of the selective hello flood attack. Again, hello flood, always to check whether the network node is live or not, whether the network is connected or not. For that purpose, in network, there is a mechanism, there is a packet which is constantly sending, that is the hello packet. And again, the capacity, if some attacker, they are sending the hello packet more than the defined capacity, then it is the kind of hello flood attacks, right? So am I audible? Hello?
Yes,
Yes.
sir.
Okay.
Yes, sir, you are audible.
Right. So there are other kind of attacks are also there. Transport layer attacks like flooding, desynchronization attacks, where the limit of the number of connections, because TCP transport layer play a very important role for establishment of the connection. You might all have studied about the three-way handshaking mechanism. Okay, TCP developed by Cerf and Khan. Okay. So these, the transport layer is also vulnerable. So like many attackers, they flood and desynchronization attacks. So there are solutions also. Many researchers, they have provided the solutions. So limit the number of connections, like from the one nodes, there should be one connection. So they limit the number of connections. They check the header, they check the full packet authentication. So using this mechanism, they may be, some researchers, they might have done other mechanism also to prevent this kind of TCP layer attacks. And transport layer protocol, there are very popular is the TCP, and wireless sensor networks works based on the TCP, not the UDP. Many cases, right? SCTP is also there but not used. So TCP, there are various kind of TCP algorithms. You might be aware about the Reno, Tahoe, almost all. You'll be wondering, almost all these TCP protocols is based on the of the America, USA, right? Tahoe and Reno, and this is used in the real time daily. You are using this kind of TCP protocols, right? So you can attackers, they can do this kind of activity to disturb the transport layer, right? Application layer, like selective message forwarding, data aggregations, data. So to avoid or to prevent these kind of things, you can have the data integrity protection, data confidentiality protection. Yes, this is the last slide. Simulation tools you can use. I think next second last slides. Very popular tools, my dear students, you can use, like NS2, but NS2 is no more because development is happening in NS2. So I will strongly suggest go for the NS3. NS2 is basically used develop for the sensor networks, for the ad hoc networks, for the basic wired and wireless networks, right? But there is not much development for last 4 to 5 years happening in the NS2. Lots of work is happening, research work using the NS3, and NS3 is validated. NS3 was developed by Tom Anderson, and Tom Anderson, we invited him at our university for one of the talk, and he has given. Right. So Tom Anderson, he has developed this NS3, and NS3 is so powerful. Most of the research paper nowadays, based on the NS2, they are not accepted for the journals or patent journals. Right. So if you have implement your work using the NS3, there are high chance that your paper will be selected. Right. So this is, so many researchers, they enhance the protocols which has been developed for the NS2 to the make compatible to the NS3. So lots of patching work is also going on, right? So TOSIM is the another, M star is the another protocol, Learnet++, JSIM, Atimo, Aurora, Sans, Puja, Castilla, Son, Visual Sense, JProwler, NetSim. If someone is interested to work in underwater sensor network, UWSIM, right? There is one emulator. Emulator is, simulations is based on the predefined, all the protocols, layering, physical layers, data link layer, applications part, right? But emulators, they straightway, interact with the hardware also. So Gsense is the one emulators. These are the three things that we have searched, and we collect it, and we are presenting if you are interested for this thing. There are huge security challenges, right? We have discussed. So encryption is always requires the extra processing. Secure asymmetric requires the more computation power, right? And there is always a trade-off in between the resource and the energy, right? So energy and computations, right? So these are the conclusion. You can see we have started talking from the basic introduction part of the wireless sensor network. Then we cover the applications. Thereafter, we talk about the node architecture. Then we straightway jump to the the security requirements. Then we have gone through the several taxonomy of the security attacks. Thereafter, we have seen that if you are interested for the research work, you can use the simulations tools. Don't straightway jump for the real time. Better go start with some simulations tools. Do some experiment. Design your your networks. Design the communications. Establish the communications, and then specify some network parameters, and thereafter you analyze using some simulations tools all the network performance parameters, maybe the packet delivery ratio, maybe the delay, maybe the throughput, maybe the routing loads, or any other kind of parameters, right? So these all are the things that we covered, and these all are the many conclusions that I have written. But ensuring overall the holistic security in wireless sensor network is one of the major research issues where you can focus. Now, so this is the conclusion. Now, some suggestions which I have written. If you want to study really in the wireless sensor networks, ad hoc networks, or vehicular ad hoc networks, or mobile ad hoc networks, right? First, you have to do all these critical analysis to understand what are the existing strategies, what are the existing work has been done for the particular applications, what kind of problems they basically focus, what kind of formulations they have made to achieve the objective, right? And thereafter, you have to formulate the performance parameters like we talked, the throughput, then delay, packet delivery, packet drop, right? Jitters, so many things are there. Performance evaluation of the basic existing. So what I suggest, first you do the comparative analysis of the existing work, and thereafter you will be finding that limitations of each of the paper. Then you try to overcome those limitations which has already been uh, you know explained by other researchers. That can be the huge research scope for your research, right? And thereafter, based on that, you propose your own mathematical model, compare it analytically, use some simulations tools like many of the simulations tools that we have talked, NS3, TinyOS, Even you can use the MATLAB, right? If someone is working in the security part, so security analysis, you can use the Wireshark, okay? And thereafter you develop your own algorithms, right? And then you simulate these things in simulators or emulators, and thereafter you do some comparative analysis, analyze what are the results that you are having in hand, and after that you learn to know how to write the research paper, right? So many times what happens, people, they work, whatever I have explained here, people, they work so hard, but they are very poor in compiling and writing the research paper, right? So again, next day or next time, sometime we will talk how to write the quality research papers, okay? And so after having your own results, you need to interpret, you need to analyze, and each of the figures that must be discussed, okay? And thereafter must be conclusion, and you have to explain your own limitations and scope, right? So that the other researchers can enhance, can cite your work, and that will be the great contribution, and work will be recognized by the international scientific community, okay? And you must also have to include the future work. So final remarks, can you think of any applications where the wireless sensor networks would be best solution? Do you foresee wireless sensor networks become ubiquitous within the next 10 years? Yes or no, right? So this is all about from my side. These are the references. These are the references, in fact, which I have referred and prepared. These 25, references I have referred, research papers to prepare these documents. So thank you. Any questions if you have, we can take, otherwise, right? So over to you, Professor Manjunath ji. Yeah, thank you very much.
Thank you, sir. Thank you so much. It was a very insightful session. So in such a short duration, you have helped our participants know the in and outs of WSN, the applications, overview, node architecture, how security is important, and explain the different types of attacks, challenges, and even which simulation tools they can use for carrying out their work. So it was a very, very wonderful talk. And now I would request the participants to please ask you any questions if they have, or they can please put in the chat box if they're not able to unmute. Yes, any questions from the participants' side?
Yeah, please. Anyone?
So till then, I would like to ask you one question regarding the implementation of WSN, any like energy efficiency, maybe using a change in different duty cycles. If we go for that concept, then how are we going to implement it? Up to simulation, we know which tools to use and all, but later, how can we actually implement the entire thing?
Yeah, so madam, you need to first, the same point, the which applications you focus, like energy everywhere is required, right?
Yes.
Even if you want to focus on the underwater sensor network, so simple, small sensors, you can purchase it, okay? And you can deploy in a small tub, okay? And then you can check it, the kind of the energy and other parameters that you are telling, right? So this is the small, ultimately you have to create a kind of the network scenario, right? So you can create the sensor for the energy conservation, like I'm telling that small tub you take, put it water over there, put it all the sensors inside it, and then you fix all these parameters, and then let the sense all the nodes sense the data, and put it on somewhere in the cloud, and then analyze it, right? So this can be, and there are various energy conservation mechanism are there, right? But again, the application to applications it differs, so you can refer. I hope I
Yeah.
satisfactorily answer your
Yes, sir.
questions.
Yes,
Yeah.
sir. Thank you, sir. Yes, I think there are no questions coming from the
Excuse me, ma'am.
student side. Yeah, tell
One
me.
question. How do we make sensors like so that
Yeah. Yeah. Very good question. Yeah.
we can get into different energy conversions easily or better? Like how do we make them?
See, this is not my area of research. In fact, electrical, you people, you can actually work on this. Okay. I mainly work in the network area, but of course, I mean, the company which are developing the kind of the sensor networks, you can explore it, right? So I'm not much aware of the development of part of the nodes. Okay, so I hope this is the answer from my side, right? Because I'm the computer science people, right? So I mainly more focus on the side of the transport layer and network layer. But obviously, so many research work, in fact, is going on in like we talk about, the adding some new features in the sensor nodes, like localizations, solar power, like energy that you are talking, Professor Mr. Rathan, right? So these many industry people they are working in this area, right? So obviously we will explore. You meantime also explore I mean. What are the? There are so many industry that they develop the kind of the nodes, right? And most of the nodes, sensor nodes like University of Berkeley, UBC, University of California, they also have developed some of the nodes there, but they are having said their own limitations, right? So many industry people they have developed the kind of nodes, and most of the development of the in sensor nodes by the European country or China or Taiwan, right? Maybe due to the Make in India, maybe some company in Bangalore they develop. I'm not aware. We need to explore it, right? So you can explore or you can collaborate with some industry people, those who are working especially for designing the sensor nodes, right?
Okay, thank you, sir. So we have one more question from Ritvik Rai. What are some good resources to refer to learn more about sensor network security?
Lots of paper are
So,
there. You can refer. In fact, uh, like we have talked all the security attacks and issues. So through the research gate, first you become the member of the research gate. If you are having the college library, online library, IEEE Springer, you can download those kind of papers. Okay, but very first part is to have the critical analysis and learning what other people, research community they have worked, because ultimately even in the PhD you also have to do some comparative analysis at the last. So you need to understand what the security mechanism provided to prevent the kind of the wormhole attack, what the security mechanism provided to prevent the kind of the sinkhole attack, right? So Sibyl attacks. So initially you need to refer the good quality papers of the journals which are published in the highly impact factor journals, right? Maybe the IEEE, maybe the Springer journal, right? Or SEM journal you can refer. But you start your if you are the novice in researches, you start with critically analyzing and studying the existing work of the particular securities area. Okay, from there you can start your research work, right?
okay, thank you, sir. Any more questions, students?
Thank you, Ritvik Rai.
Yes, sir. Students, as sir has provided us with so much of knowledge about WSN and its security, I request you all to take up some interest in this area and carry out your research work in WSN, as it has a great future. So I would also request you to please share the PPT with us. It will be very useful for our students. And surely, as you said, we would like to hear some more things from you about how we should be publishing the papers in good journals. And now,
Yeah.
students, we will be sharing the feedback link to you in the chat box. Kindly fill the same. It will be put in the chat box just after vote of thanks. So just wait for a minute. And now I request Dr. Shashi Raj, Assistant Professor, Department of ECE, DSE, to propose the vote of thanks.
It's a very good morning to one and all. It gives me an immense pleasure to deliver vote of thanks for this wonderful event. On behalf of the Department of Electronics and Communication Engineering, Dayanand Sagar College of Engineering, I, Dr. Shashiraj K, express my heartfelt thanks to Dr. Nirbhay Kumar Chaube, a professor and dean of computer science, Ganpat University, Gujarat. He is also one of the well-known personalities in the wireless sensor network domain in India. Thank you for accepting our invitation to be the speaker for today's webinar, sir, and enlightening all of us about the insights of wireless sensor networks, especially its advancements, design issues, and the security issues, including the taxonomy of attacks. Once again, I thank you very much for accepting and being with us, sir. Thank you. So I would also like to thank the management of Dayanand Sagar Institutions, Dayanand Sagar College of Engineering, our beloved principal, Dr. CPS Prakash sir, and our beloved HOD, Dr. TC Manjunath sir, for providing motivation and support in conducting this webinar. And I would like to thank our fellow coordinators, Dr. Pavitra Ji Madam and Professor Trupti Tagare Madam, and all the staffs of our department and the participants for making this event a successful one. Once again, I thank everyone. Thank you all.
Thank you, Professor Shashiraj Ji, Trupti Madam, Pavitra Madam, and a special thanks
Thank you,
for
sir.
the entire management of Dayanand Sagar Engineering College and my dear friends, Professor Manjunath Ji. So thank you and namaste everyone. Okay, see you sometime.
Thank you, sir.
Yes,
Thank you.
thank you,
Thank
sir.
you,
So
sir.
I'm leaving.
Shashiraj
Yeah.
sir?
Thank
Yes, sir.
you. Yeah.
Thank you. Shashiraj sir, kindly share the feedback link in the
Yes,
chat
ma'am.
box.
Yes, it's shared, ma'am.
Yes. Students, fill the feedback link, as it will be open only for some time. I'll stop the recording, sir.